Hello and welcome to this video where we're going to be finding the nth term of sequences. So before we were given the nth term and we had to generate the sequences. Now I'm going to be giving you the sequences and you have to work out what the nth term is. Now at the end of the first video we noticed something very important for this, and what we noticed is that the coefficient of n, the number written in front of n, is what the difference is. Now that is incredibly important because that is always going to be the first way we work out a first part of the nth term. Now I'm going to be showing you two different methods for this, and depending on what the sequence looks like, one of these might be a little bit better than the other. They'll all work all the time, but one of them might be easier than the other. Now the general way that the nth term looks is it's going to be something multiplied by n, and then add a number or maybe subtract a number. But this is the general way that it looks. Now, we can always work out what this value for d is, the number in front of n, the coefficient of n, based on what the difference is. So here, I'm adding 5 each time, which means this is going to roughly look like 5n. So it's going to be 5n, and then there's going to be a correction afterwards. Now, what does 5n look like? 5n is 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5, 5 times 6, and so on. It's just the 5 times table. So what we need to think to ourselves is, what do I need to do to 5n to get the sequence? And what you should be able to see here is, I'm just adding 2 each time. So this sequence is 5n add 2. So here, this method is called the shifted times table method. D, the number in front of n, is the difference between the terms. So here it was adding 5 each time. What is that? List these multiples above the sequence, and then C is what needs to happen to that sequence to get the sequence that you've been given. So here, let's try that again. Here, I've got 3, 7, 11, 15, 19, and so on. This is adding 4 each time. So I know that it's going to be roughly 4n. So it's going to be something to do with 4, 8, 12, 16, I do not know my 4 times tables, 20, and so on. What am I doing here to correct that? Well, I'm taking away 1 each time. So that means that my nth term for this sequence is going to be 4n. Oh, too many pens now. Oh, not plus. It is take away 1. I could technically write add -1, but I don't need to write add -1 because it's the same as 4n take away 1. A little extra tip for you. Here I wrote up +4 a lot of the times, I wrote at -1 a lot of the time. We don't really have to repeat ourselves. Once I know it's add 4, I can just look at this first term and just see, well, what am I doing to the 4 times by 1 to get this first term? Because here, D, and then add whatever C is, oh, lots of colour changes, is the first term. So here, 4 take away 1 gives me 3. On this other example, 5 add 2 gives me 7, 5 and +2, 4 and -1. So I've got 4 questions for you. I would like you to pause the video and have a try at these questions, please. And I'm going to show you the answers now. Now, this last one, where we've got a negative, might have been a little bit more difficult to work out what C is. So I'm going to show you a second method, and this second method is much easier if there's any negatives involved. If there's negatives, it can get a little bit trickier to work out what C is, so this method is a better way. with negatives. So it starts off exactly the same. D is still the difference between the terms. Here it is still adding 5 each time, so it is going to be 5n, add or subtract something else. Now all I'm going to do is go backwards from the first term and just wonder, what would that 0th term be? So here, to carry on that pattern, this would have to be 2, because 2 add 5 makes 7, 7 take away 5 gives me 2, and then this number is C. So here, 5n plus 2. So this is only 2 steps. D is the difference between the terms still, that's exactly the same first step. And step 2 is use the difference, go back, find that 0th term, that is C. So let's have a look at this example. A little bit more difficult. So we've got here, we're taking away 4 each time. So I know it's going to be negative 4n. Ooh, losing pens. And then I just need to go back to what this would be. Now, to carry on that pattern, that's going to have to be 34, because 34 take away 4 is 30, 30 add 4 is 34. So this is going to be negative 4n plus 34. So that's a much quicker method when I've got negatives. So I'd like you to have a go at using that method with these 5 questions, please. Pause the video, have a go, and I'm going to show the answers now. So what I would say is the 0th term, definitely really, really easy most of the time, but I would say the shifted times table is probably going to be a little bit quicker on the first and the 5th one. When we've got positives, then we know that here 4, difference of 4, add 3 makes 7. Here, difference of 5, 5 take away 3 is 2. I would say the shifted times table is quicker on these first and last ones, and then these ones which involve negatives, the 0th term is definitely going to be the better method. Doesn't matter which way you use, whichever you'll find is best, they'll work, but sometimes it might be quicker if you think about it. One might be a little bit easier than the other. So I want to make sure that we know exactly why this works. I want this to be completely justified for us. So we're going to have a look at the underlying algebra. We have this is the generic nth term. This is what it's always going to look like. Well, if this is what it always looks like, let's find out what the first term is. So the first term is going to be d times by, well, n is going to be 1 for the first term, and then plus c. Oh, I'm going to be fiddling with a lot of pens for this bit. And then, well, d times by 1 is just d. Plus c, there's the blue pen. So here, my first term is just going to be d plus c. Next, the second term, well, that's going to be d times by 2 for the second term, and then still adding c on the end. Now, d times by 2, remember we don't write the time symbol, we write the number first. That is just going to be 2d plus c. So there, that is my second term, 2d plus c. My third term, I don't think I need to do the whole working out for all of this. Hopefully you can see that this is going to be 3d plus c, and my fourth term is going to be 4d plus c. Oh, too many pens. Now, here I've got my first term, my second term, my third term, and my fourth term. What we can see here is, how do I get from d plus c to 2d plus c? Well, I'm just adding d. Here to 2d plus c to 3d plus c, I'm just adding d. And again with my fourth term, 3d plus c to 4d plus c, I'm just adding another d on again. So this is why the number that's in front of n is just what the difference is. And we can also see that my first term is d plus c, just like I said with the shifted times table. So that's why it works, because that's what it always is. It's always d plus c for the first term. Let's have a think. What would the 0th term be? Well, here, if I'm carrying on that pattern, I'm going to have to take away d here and just be left with c. That's why the 0th term works, because the 0th term is just c. So, as I said, each method is always going to work. Doesn't matter which one you use. They should get you the right answer, but if you think about it, one of them might be easier than the other. Thank you.